So, good morning, everybody. Today, I am going to discuss in very fast the short notes, or you can say very quick revision of class 9th physics of all the chapters. Today, I'll discuss all the chapter like motion, force and laws of motion, gravitation, work, power, energy, and sound. So, please keep noting. I'll discuss very fast. I'll go. So what is physical quantities? Physical quantities are grouped in two categories, which are scalar and vector quantities. So these are the quantities through which we can measure anything, you can say that. So two type of physical quantities are there, that is scalar quantity and vector quantity. Write down the difference. In a scalar quantities are specified by magnitude only. Only magnitude will be there in scalar quantity. In vector quantities are specified by both magnitude and direction. In vector quantity, both direction and magnitude will be there. Second point is scalar quantities change with change in magnitude only. Scalar quantity change with change in magnitude only. In vector quantity change either with change in magnitude or with change in direction, or with change of both magnitude and direction. Third point, scalar quantities with same unit can be added or subtracted according to the ordinary rule of algebra. But vector quantities cannot be added or subtracted algebraically. Please keep noting. Fourth point is, these are represented by ordinary letters. In vector quantity, these are represented by bold-faced letter having arrow over them. उसके ऊपर arrow रहेगा. A vector, read as vector A. So example can be scalar quantities is having length, mass, volume, density, speed, electric current, work. These all things are scalar quantity. And in vector quantity, displacement, velocity, acceleration, force, linear momentum, etc. Now, what is origin? It is a fixed with respect to which the position of any object. So this can be called origin. It is fixed with respect to which position of any object. What is motion? Write down. When an object changes its position with time, it is said to be in motion. When an object changes its position with time, it is said to be in motion. What is rest? When an object does not change its position with time, the object is said to be in rest. When an object does not change its position with respect to time, the object is said to be in rest. Now, two things are there, distance and displacement. So, in distance, write down point number 1. Total length traveled by an object between final position and initial position. Total length traveled by object between final position and initial position, that is called distance. Displacement, shortest distance between final position and initial position. Shortest distance between final position and initial position. Second point, in distance, it is a scalar quantity. In distance, it is a scalar quantity. It has magnitude, no direction, as I had already discussed earlier. Second is displacement. It is a vector quantity. It has magnitude as well as direction. So in this way you can see here distance between A and B. So the path 1, then path 3, this will be the total distance. So total distance A to B is path 1 plus path 3, that is called distance. And in displacement between A and B, that will be the path 2, that will be the A and B, distance between A and B, that will be the path 2, so it's called displacement. So now write down, distance traveled is always greater than or equal to displacement. Write down notes point, distance traveled is always greater than or equal to the displacement. So distance is greater than equal to displacement. Please keep a boundary line on this, important notes. Now speed. The rate of change of distance is called speed. The rate of change of distance is called speed. It is a scalar quantity and the SI unit of speed is meter per second. Meter per second. So distance by time, that is called speed. Average speed, total distance traveled by total time taken, that is called average speed. Average speed will be total distance traveled by total time taken. Now some important formula to find out average velocity. So average velocity vector V, that will be S1 plus S2 plus S3 plus dot 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 Sn by T1 plus T2 plus T3 dot 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 Tn. Now second point V, that is S1 plus S2 plus S3 dot 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 Sn divided by time can be written as S1 by V1 plus S2 by V2, that is total time taken. Total time taken. So, and now C, formula number C is vector V, that is equals to V1 T1 plus V2 T2 dot dash dash Vn Tn divided by T1 plus T2 plus T dot 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 Tn. So these are the important formulas of average velocity. You can write and keep a boundary line on that. Now instantaneous speed. Speed of an object at particular instant of time. Speed of an object at particular instant of time is called instantaneous speed, that is can be written as ds by dt. ds is change in distance and dt is change in time. So now velocity. The rate of change of displacement is called velocity. The rate of change of displacement is called velocity. So velocity equals to displacement by time. So now you can write S2, displacement S2 minus S1 divided by T2 minus T1. So velocity is vector quantity. So velocity is vector quantity. The SI unit of velocity is meter per second. The SI unit of velocity is meter per second. Average velocity equals to net displacement by total time taken. Average velocity equals to net displacement by total time taken. So average velocity is equals to net displacement by total time taken. Equation of motion for uniformly accelerated body. Now next point is equation of motion for uniformly accelerated body. So please write down V equals to U plus AT. V is the final velocity, U is the initial velocity, and A is the acceleration and T is the time. So V equals to U plus AT. Second point is S equals to UT plus half AT square. S equals to UT plus half AT square. Third point is V square equals to U square plus 2AS. V square equals to U square plus 2AS. Now fourth point is, suppose you have to write for S nth, then you can write the formula of sum is equals to as I've already told you now, I've already told you that U is the initial velocity, V is the final velocity, A is the uniform acceleration, T is the time, and S is the displacement plus height. So if a particle is thrown vertically upward with initial velocity U, if a particle is thrown vertically upward with initial velocity U, then equation of motion becomes V is equals to U minus GT. And the second one is S equals to UT minus half GT square. S equals to UT minus half GT square. And the third one is V square equals to U square minus 2GS. So once again I am telling you V equals to U minus GT. S equals to UT minus half GT square. And last one is V square equals to U square minus 2GS. Now maximum height attained by that particle is equals to U square by 2G. Maximum height attained by the particle is equals to U square by 2G. And time of reach to the maximum height, that will be equals to U by G. Time to reach to the maximum height, that will be equals to u by g, and the time of the flight will be 2u by g. You can find all these equations by keeping the value of equation 1, 2, 3 in that, and you will get all the results. So the time of flight will be 2u by g. Now angular displacement. Angular displacement, that is length of arc of a circle by radius of the circle. Angular displacement, length of arc of the circle by radius of the circle. So theta equals to L by R. So angular displacement theta is equals to L by R. Length of arc of the circle by radius of the circle. So angular displacement, length of arc of the circle by radius of the circle, that is theta equals to L by R. Now angular velocity. Now angular velocity omega, that equals to theta by t. That is angular displacement by time. Angular velocity is equals to angular displacement by time. So angular velocity is equals to angular displacement by time. So omega equals to theta by t. Angular displacement theta by t. Unit of angular displacement in radian. Unit of angular displacement in radian. Now relation between linear speed and angular velocity. Relation between linear speed and angular velocity. Please write down. V equals to omega r. V equals to omega r, where V is equals to linear speed and omega is called angular velocity. V equals to linear speed and omega is called angular velocity, and r is called radius. Relation between linear speed and angular velocity. V equals to omega r, where V equal to linear speed, omega angular velocity, and r is radius. Acceleration, the rate of change of velocity, it is called vector quantity. The rate of change of velocity, it is called vector quantity. So acceleration is equals to velocity by time. Acceleration is equals to velocity by time. You can see in the graph also, velocity time graph will give you the acceleration. And its unit is meter per second square. Its unit is meter per second square. So acceleration is equals to final velocity minus initial velocity by final time minus initial time. Acceleration is equals to final velocity minus initial velocity by final time minus initial time. So acceleration equals to v minus u by t2 minus t1. Acceleration a is equals to v minus u t2 minus t1. So slope of displacement time graph will give you velocity. Slope of velocity time graph will give you acceleration. And the area under velocity time graph indicate the displacement of that object. So please keep noting, these are the very important point which will be helpful for you all in solving the numerical problems. The area under velocity time graph indicate displacement of the objects. So now we will move ahead with next topic, that is the force. The interaction that can cause a change in velocity of a particle like body. The interaction that can cause a change in velocity of a particle like body, it is called force, or you can say pulling and pushing is also called a force. It is a vector quantity and unit of that is Newton. Unit of that is Newton. So force is divided into two parts, that is contact force, and the second one is field force, that is non-contact force. So in contact force, write down the force that act on the body when they are in actual contact. Contact force is the force that act on the bodies when they are in actual contact. Now the second point is field force, non-contact force. The force that act on the bodies without being touched. The force that act on the bodies without being touched. That is called field force, non-contact force. So that is gravitational force, magnetic force, electrostatic force. So these are called field force. And in contact force, frictional force, normal reaction force, these are the contact force. Please keep noting. Now also these are divided in three parts, that is balanced force, unbalanced force, and resultant force. So in balanced force, when the resultant force on the body is zero, that is called balanced force. When the resultant force on the body is zero, then it is called a balanced force. Now unbalanced force. When resultant force acting on the body is not equal to 0, that is unbalanced force. When the resultant for acting body is not equals to 0, that is called unbalanced force. You can say this one is that the angle between F1 and F2 is called theta. Now resultant force. Many forces may be simultaneously applied on the body. So the resultant will be root under F. Suppose that two forces are applied on the body, and the final resultant force will be root under F1 square plus F2 square plus 2F1 F2 cos theta. F is equals to root under F1 square plus F2 square plus 2 F1 F2 cos theta. That is called resultant force. Now, Newton laws of motion. There are 3 laws of motion given by the Newton. Please keep noting. Newton laws of motion. So 3 laws are given by the Newton. The first law is, without external force, body does not change its state of rest or motion. The first law says that without any external force, body does not change its state of rest or state of motion. The second law says force is defined as the product of mass and acceleration. Mass and acceleration. The force is directly proportional to the product of mass and acceleration. Third law is telling that every action has equal and opposite reaction. So F12 is equals to minus F21. Now, once again I am repeating. First law, without external force, body does not change its rest or motion. Second law is saying force is defined as the product of mass and acceleration. So friends, please keep noting. If any doubt will be there, then you can ask me. Okay, if any doubt will be there, I will going very fast, because as you have already completed all the things, so I am just making it very quick so that your time will be saved. Okay, so the third law, I had already said that every action has equal and opposite reaction, that is F12 is equals to minus F21. Third law. Now inertia. The tendency of a body to maintain its state of rest or motion in a straight line is called inertia. The tendency of a body to maintain its state of rest or uniform motion in a straight line is called inertia. So there are 3 kinds of inertia: inertia of rest, inertia of motion, and inertia of direction. So inertia of rest, tendency of a body to continue in its state of rest. Please write down, tendency of a body to continue in its state of rest is called inertia of rest. Inertia of motion, tendency of a body to continue in its state of motion, that is called inertia of motion. Now inertia of direction, tendency of a body to oppose any change in its direction of motion is called inertia of direction. Tendency of a body to oppose any change in its direction of motion is called inertia of direction. Now mass and weight, very important topic also. People are getting confused in this mass and weight. Write down mass. Mass is a property of body. It is measure of body's inertia. Okay. Mass is the property of body. It is a measure of body's inertia. Now weight. Weight is a force. Weight is a force. The force of gravity on a body. The force of gravity on a body. The second point is SI unit of mass is kg. SI unit of mass is kg. And the SI unit of weight is Newton. Third point is mass is a scalar quantity. Mass is a scalar quantity. So now weight is the vector quantity. Weight is a vector quantity. Please keep noting. Once again I am repeating, mass is a property of body. It is measure of body's inertia. Weight is a force. The force of gravity on a body. SI unit of mass is kg. SI unit of weight is Newton. Mass is a scalar quantity. So weight is a vector quantity. Weight is a vector quantity. Now momentum. Momentum of body is defined as, please write down, Momentum of a body is defined as product of mass and velocity. It is the product of mass and velocity. You will also learn all the things in very deep in class 11 topics. So momentum is equals to mass into velocity. So P is equals to mv. Momentum is equals to mass into velocity. P is equals to mv. Now next point is friction. An opposing force that come into play when one body actually move or even tries to move over the surface of another body. What is friction? An opposing force that comes into play when one body actually move or even tries to move over surface of another body. So friction has so many types like static friction, limiting friction, kinetic friction, rolling friction. So there are so many type of friction. So if any doubt will be there, you can ask me directly. And I think we will have to stop for today. Okay. So we'll continue with the next short notes of different chapters, that is remaining 3 chapters, that is gravitation, work, power, energy and sound in next class. Thank you and have a nice day.